Hello everyone, this is Ramakant Gupta. I have total 17.5 years experience in IT industry. I am currently working as a senior engineering manager, plus a technical architect and a full stack developer. That's it about myself. So let's go to the session. Today's topic is about top command. What is this top command and how it's going to help me to understand my day-to-day activity? Top command is used to measure the system performance, to understand the resource utilization on my machine. Right? It's basically used for lot of activities. It's used to display the real time information about the running process, understand the system performance, understand the CPU utilization, memory utilization, running process information, load average on my system uptime. All this information can be easily get via this top command. So let me quickly take you through the command and we'll understand each and every parameters in the top command. So when you type, let me just show you, when you type a top command, it will give you all this information, right? Here lot of information is hidden. If you understand this top command properly, you will be able to understand or visualize the system performance. You will be able to understand in your system or in your application if any issue occurs from the performance perspective. Okay, so let me take you through each and every item which is getting displayed using this top command. Okay, so if you see at the top left corner, it displays the actual time of your machine. So currently it's at 3:42 p.m. and 16 second. Okay, uptime, what is this uptime? 10 minutes. So this is the time since my system has rebooted, right? So 10 minutes before I started my system, that's why it's showing 10 minutes. Okay, this one user indicates how many users has logged into your machine, right? Currently on my virtual VM only one user is logged in, so that's the reason it's showing one user over here. Load average, what this load average does, this load average helps me to understand what is the average load on my system, right? So let me take you through this PPT. Okay, so this load average signifies load at different interval. One is at 1 minute, one is at 5 minutes, and one is at 15 minutes. So if you see the first value, it indicates the what was the load average at first minute. This value indicates what was the load average at 5 minutes. This indicates what was the load average at last 15 minutes. This helps me to understand my system performance, how it's going to help. This load average will tell me how many processes, what is the actively running processes on my CPU. In this is total number of active running process which causing the load on my system. How many processes which are waiting for CPU time, how many processes which are waiting for IO, right? So basically how this parameter will help me to understand my system performance. So let's understand a simple example. So here I have given below CPU capacity, at CPU capacity, and above CPU capacity. So let's understand a simple example. I have a single core means a single CPU, and if the load average is 0.50, what that means, my load average is half the CPU capacity, right? Let's understand the second point. I have same single core CPU and my load average is 1.0. What that indicates, my CPU is 100% utilized, right? Let's take the second example. If the load average is beyond 1.0 for a single core, in the sense your CPU is fully utilized, right? It's beyond 1.0, it means your CPU is overloaded, right? So let's understand this three significant term: system under heavy load, idle system. When I will say my system is under heavy load, when I will say the system is idle, or when my system is getting consistently heavy loaded, right? So let's take a simple example. This example is shown for a dual core CPU. What is a dual core CPU? There are dual means two, right? So there is two CPU, right? So if you see load average 3.5, so what that means, ideally how much should be the load? It should be 2.0 because there are two cores, right? But it's beyond 2, it means my system is heavy loaded. If you see 2.8, again it's a beyond 2, it means it's a again heavy loaded. 1.9, it's a closer to the resources available in my system, right? So it's almost fully utilized, my CPU is fully utilized. Okay, idle system, again the same example, we are considering 2 core CPU. So here 0.05, if it's a 2.0, in the sense my system is fully utilized, but it's a 0.0, it means it's a below the system capacity, right? So it's a idle system. Okay, this example idle system. Let's take this example. So let's take example where I have 4 CPUs, right? In this example I have 4 CPU. So here if I say ideally how much load should be 4.0, right? But here you can say 8.0. So what that means, it's twice the number of processor, right? And again in the next 5 minutes it's increasing the load, right? It's increasing the load, so it's going consistently, the load is increasing, right? 7.9, the load has come a bit down, but again it's beyond the capacity. Okay, now let me quickly take you to the second part of this example. Okay, so this was about the load average. Understanding this parameter, we can understand how much my CPU is loaded or how much my system is loaded. Okay, let's understand what this task parameter. So if you see this task is nothing but number of processes. Let's take a simple example, it's nothing but a number of processes. So what this total number indicates, how many numbers of currently running processes on my system. This can include everything, all the process state, from running to sleeping to stopped or zombie process. All the process on my system is a count, is a total number of count. Okay, running means this actually just involve the running process. This is the process which is actually taking the CPU time. Sleeping, the sleeping process is not currently executing, but it's a waiting for some resource. The waiting could be anything, it could be for IO, user input, or any kind of signal from some other process. This process also is taking the CPU time. Stopped processor, this process is either manually killed via some kill -8 command, right? It's this process is not at all consuming the CPU time. Zombie process are those processes which is killed or which is not, it has been, the execution has been completed, but its a parent process is not aware about its a execution completion. That's the reason it has not been removed from the process table list, right? Now here also one catch, zombie process does not harm to the CPU, but even if you have continuously increasing number of zombie process, so obviously there is a alert for you. So we need to see like what is the reason the parent process is not able to release that processor from the process list. Okay, now let me take you to the let me take you to the CPU utilization. So this also parameter is very important to understand the system performance. It has a lot of output. This is a user space, this system space, this is niche space, this is idle time, this is waiting. Like this, there are a lot of parameters to understand about this. So let me take you one by one all these parameters. So let's take this simple example. So what is this user percentage? So this percentage indicates the percent of CPU time spent on in user space by the process, right? What is the user space? So user space is nothing but like just like on Windows machine we open the text editor, right? So similar in Linux, if you have some if you open some Chrome browser, or you have opened some text editor, or you have some custom scripts, right? So those processing time which it takes, it's considered under the user space. Okay, system space. So this is nothing but the time or the CPU time spent by the process in the kernel space. It could be anything. It's nothing but like a system call, right? Suppose that whenever you call a uuid command to generate uuid, that command get executed under the kernel space, right? So that indicates how much time the kernel has taken for creating or generating the uuid. Okay, nis value or nice value we say. So this this what this value indicates, this value indicates how much time the CPU has taken for adjusting the priority. Suppose that you have hundreds of processes, right? So CPU internally define the priority of the process. This value shows this here, this value shows that how much time the CPU has taken for adjusting the priority, idle. So this value indicates the percentage of time the CPU was idle, or in the sense not doing any processing. IO wait, IO wait. This indicates the how much time the CPU has waited for IO operation. IO operation could be anything. It could be network IO, it could be disk IO, anything, right? Hardware interrupter. So this is like, suppose that you are typing from the keyboard, right? So this is nothing but hardware interrupter. You are typing from the keyboard, so it's interrupted due to that input from the keyboard. Software interrupter. So there are a lot of interrupt from the software side also. Is still time. This is basically used for the hypervisor. Currently we are not using this one much, but it's basically for hypervisor kind of systems. Okay, this two parameter indicates the memory, right? Memory utilization, and this is the swap related memory utilization. So let's understand what is the memory and swap memory utilization. Okay, so before going there, I just wanted to give you more information what this CPU utilization means. If the here I shown there is a user space, this user space and this system space. So let's take couple of examples. In case we have higher user space and low system space, what that means, there is some application program which is consuming lot of CPU space, CPU memory, right? CPU utilization is doing, right? So that means there is some heavy computation which is done within your application. That's the reason your user space is increasing, right? High system and low user space. So high system mean in the what, the kernel is doing lot of IO operations. It could be network related, or it could be hardware related, it could be writing to the files, this kind of IO operations, right? Sometimes because of the disk writing is slow, so that's the reason you will get a high system. Okay, balanced in the sense like system space and user space is not that much high, so that's a balanced user system space. High user and high IO indicates application are waiting in IO, possibly causing bad bottleneck. So let's take one simple example. From your script or from application, you have executed a select statement which is running in the database, right? And your system is waiting to get the output, right? So that is nothing but a IO operation. It's nothing but an input output operation, right? So yeah, that's one scenario where you will have high user and high IO. Okay, now let me take you to the memory utilization. Okay, so in memory utilization, there is a total, there is a free, there is used, buffer and cache. It has some indication, right? So total means how much is your total memory on your machine. So here, as per the example, if you see this example, this indicates a total 8 GB of space is there on my machine, right? Free means the space which is not at all used by the application, right? Free indicates that it is not been allocated to any process, cache or buffer, anything. That space is entirely idle, right? Used means used indicates the process, the total amount of memory that is used by the process. So here it indicates 2 GB of space is being used. Buffer and cache. So this space is very important from the system perspective. This space is also considered under the free space. So let's understand what is a buffer and cache space. Buffers. Buffer is nothing but temporary storage used to speed up disk IO operation. And what is a cache space? Memory used to store frequently accessed data. For example, file system data. So let's take a simple example. Suppose that you have some process coming up which requires a RAM, right? And we don't have sufficient space in the RAM. So what RAM will do, kernel will do, it can free up the buffer or cache space and move some pages from your RAM, and it can move some data. Okay, let me come again on this buffer and cache space. So suppose that your application, there is some process which requires some RAM or some memory, right? So what kernel can do? The kernel can remove the buffer or cache data and give the space to this the additional process, right? Okay, now coming to the swap memory details. So what is the swap memory? Swap memory is nothing but an additional RAM, or we can say this memory, this is an additional memory. Sometime in most of the systems this is not a high performing memory. It's the memory is something like HSDD, right? Right. So so now question like when the swap memory is used. The scenario is like when you have RAM which is exhausted, so kernel may internally decide to move out the pages from a RAM to the swap memory and give the space to the process, right? Now here there are some complication, there are some performance related ticks involved over here, or some performance related indications are there when we understand the swap memory. So in case we have a high swap uses, what is the high swap uses? So this indicates that there are a lot of swap in and swap out is happening, right? In the sense there is a movement of data or movement of pages from your RAM to the swap memory. If lot of this swap out happens, in the sense your system is, there is some shortage of the RAM on your system, right? So in that scenario you have to increase the RAM space, right? Because swap memories are always slower than the RAM memory. Low swap uses, if you have low swap uses, so that indicates that you have the sufficient RAM to do your functionality. Free swap space. Free swap space does not have any negative impact if it's a free, in the sense you have sufficient RAM and your system is performing properly. There is no concern. Okay, now let me take you the next task. So this is nothing but a task, this is nothing but a all the processes which is running on my system. So let me take you one by one point. What is this PPID, what is this PID, what is this user, and all this information. This is very important. And then next I will show you what are the different input parameter you can give to measure the different performance of a to measure the performance of your application. Okay, so PPID is nothing but parent process ID. PID is nothing but a process ID given for every process in Linux operating system. User, the user who owns the process. PR is nothing but a priority of the process. If we have a low number, it means it has a highest priority, and if a high value, it means it has a low priority. And NIS value is nothing but, it's nothing but the particular process how nice it is to the other processor. In the sense, if it has a higher value, it means it is very nice to the other process. That indicates like it is giving high priority to the other processes. If it has a negative value, it means it is not nice to the other processes. It means it is, that process is having a high priority than other process, right? Virtual, this is the total memory used by the process. It includes all the memory that is nothing but a code, data, shared library, etc. Residential memory, this is the actual memory that is used by the process. This is whenever your application comes up, that application how much memory takes up, that is this residential memory. Shared memory, this sometime what happen, you suppose that you have Java processes, right? Java processes have some libraries, right? They uses the Linux library, or they have some libraries. So all the Java processes share the same libraries, right? So this amount of memory indicates how much shared memory space that particular process is using. S state indicates the status of the process. S means sleeping, R means running, Z means zombie, and T means the process stopped. Percent CPU, the percentage utilization of the CPU by that process. Percentage memory, the percent utilization of memory by this process. Time plus the total time used by the process since it started, right? Here in the time there are two things. One is like accumulated time, and one is like it's a summarized time. So accumulated time in the sense like that process may have multiple threads, right? So that accumulated all the time taken by the thread plus this process indicates the accumulated time. Command is nothing but what command is executing for that process. Okay, now let me take you to the different options which I can use with this stop command to understand the different behavior, or to analyze my performance on my system, right? So I will tell you very simple way. You can just type H. This is like help. So all this information is given about how to use this top command. So let me take one simple example. Z means to display the color. So now you can click or type Q. Okay, let me type control shift Z. Okay, shift Z, what it does, it give you the information how you want your top panel to be displayed, right? So if you just see over here, you want S summary data, you want message prompt, you want column head, task information. You can select each option and you can give different color. Just like let me select a summary data. So I will shift S, and what color you want. See if I want red color, so you can select one. So if you see summary data, this is summary data, it's coming as a red color. I want a green. See, this summary data is coming as a green color. Now let me give head column H. So this is become head. Now for head column, this is a head column, right? Column head. What color you want to give? Let me give 3. 3 is for yellow. Let me give 7 white. So this is white has come, right? Let me give 5. Okay, similar way you can give task information, right? This task information, let me give T. I can give red. Okay, so you can see like the color has been changed. All the color has been changed. Now similar way, like I can go to the H. You can different option you can select. You can select B for bold, E for displaying the memory scale. So what is this E? Let me just show you. So if you see over here this memory space, it's currently displaying the data in KB, but you want in GB. So shift E. See, it's displaying the data in GB, right? Again you want to change the format of data, or in the sense in different unit you want to display the data. So again press shift E. So now it's displaying the data in terabyte, megabyte, exabyte, right? Again I came back to the KB. I can display in MB. Okay, similar way here there is again some memory, virtual memory, shared memory, residential memory. This I want to display in different unit. So small e. See, it is coming in MB, this in MB, this in MB. Okay, let me go to other help. Okay, so here you can toggle in case you don't want to display the load average, you don't want to display the CPU, you don't want to display the memory, so you can select this option LT. Like, let me just show you L. So if you see, you just observe over here, L gone, the load average gone, right? T, if you type task, gone, right? M, if you type memory, gone, right? If you type, so here if you see, it is displaying you all the list, all the summarized view of all the CPUs which is available in my system. So you want to list out the CPU wise load on your system, so you can type 1. So if you type 1, there are two CPU 0, CPU 1, and each CPU, what is the user space, what is the percentage user space, system space, then NIS value, idle time, all those information you can get displayed. Okay, sometime you want to add some field, right? Sometimes you want to add some field, just like you want to have some additional field, or you don't want suppose that this yes column, so you can type F. So if you go H, here if you see F, right? Let me quit and come back here, F if you type. Okay, just scroll up and down. I told I don't want yes process status, you can just space bar. Okay, that won't be displayed. Let me just show you, quit and come, see, yes has gone, right? Let me again, F. I want to sort that, I want to shift this column, suppose that I want to shift this memory utilization. So how you can do, you can right side, you can select the right arrow, now you can shift up. See how memory is coming up, right? Memory column is coming up, so now it has shifted. Now enter, that's it. And the CPU, suppose that you want to shift. Okay, so right side, all the information you can read out over here and you can understand, right? CPU you want to shift. Okay, so percentage CPU you can shift. Okay, enter and skip. So you can see that PID, then memory, then percentage has come. Okay, let me go and give you some more information. Okay, there is a locate, you want to locate some string, so let me go and type shift L, right? You want to string something, suppose that there is some process running with my ID, so I can locate. So you see, it has located that string, right? Okay, now okay, I need to let's understand this column. Toggle highlight X, okay, and Z for color or mono, B for bold. So let me just X, Z, B, it has highlighted, right? Now you want to change this sorting. So basically what is happening, now your data is sorted by this time, right? Your data is sorted by time. Now you want to shift this sorting to, let's understand, based on the virtual memory. So shift and back arrow. Okay, now it's a sorted based on virtual memory. Now you want to sort this data based on the ascending or descending order. So you can type shift R, it's from descending order. Now again toggle, you can, it will come into the shift R, again it will come into the ascending order. Now go. So here we have seen X, Y, Z, B, sorry, X, Z, B, okay, and R means sorting. Okay, now here there is a Z column, number justify. So suppose that you have some numeric values, right? So if you type if you see, right, it will be number justified. So shift J, it is shifted left side, right? This value is shifted left side, this value is shifted because these are numeric. Similar way, string small j, see, you can see column, how you see, right? This string small j, it's a justifying, left right justifying. Okay, you want to see the processes which is running by particular order, so you type U and then okay, so it will only list the processes which is running by particular order. So this way it will help you to understand, or you can debug a particular process you want to debug, right? You want to debug by a particular CPU utilization, you want to debug a particular memory utilization, sorry, right? All those things you can do over here very easily. Okay, so now now there is a few more things. Let me take you a few more example. Now suppose that what happened, you are monitoring the performance of the system, right? And parallelly you want to check how much CPU utilization for a particular processor, or you want to do the sorting based on CPU utilization, based on memory utilization, or multiple parameters, right? But then what you can do, you can open 4 top command, and you can, each window you can see, in some window you can see CPU utilization, in some window you can see memory utilization, in some window different kind of utilization. But there is one more feature, that is like you can split the window into 4 part, right? So let me just show. I type H, then this output has come. Again if I type H, again this output will come. So this, there is a parameter, there is a A, W, some outputs are there, right? Some input is expecting, just like A is that to go into that mode where it can split the window. So let me type shift A. So it has splitted my window into 4 part, 1 2 3 4. I want to switch through between this window. So this is, just monitor over here, this is the name of the first window. If I type A, this is the name of the second window, and this is shifting. This is the name of the third window, and this is the name of the fourth window. Let me just give the name. So let me see what is the help required to give the name. So G, capital G is the changing the name of the current window. So let me shift G. So I can see I want to sort and based on mem. So let me give mem. So this is based on memory. Again let me shift to different window. That is a small a. Now this is second window. I want to change the name. I can see CPU based. I want to change. I want to do the sorting. Okay. Now third one is, let me do the sorting based on the residential memory. So switch to that window. I can give some name, shift G, res something. Okay. Now I see all the windows color looks the same. I want to change the color of this first window. Okay. So I can switch to that window. Okay. I showed the help how to change the color of the window. Here there is a Z, right? So you can type shift Z. It will tell you like how, what color you want to give. So the first window I want to give this color. Okay. Now let me shift the window. You want to change the color, shift Z. You can give this color. Okay. Now let me again shift J. You want to give the color. Okay. You can. Okay. A. I am now onto the third window. I want to change the color. So you can give this color. So this way you can easily identify. Now you can shift to that particular window. I am shifting to window A. Right. I can this is for memory related. So I can do this using shift and that greater symbol. I shifted to the percentage memory. I can do the sorting based on memory. Okay. Okay. Now let me shift to the second window, that is using A input, and here I want to do the sorting based on the CPU. So Z, B, X. Okay. Let me shift sorting. Okay. Now do the sorting based on CPU. Okay. Fine. Third one was based on the residential memory. So I can shift via A. So now I am into the third window. I can, okay, Z, X, B. Okay. B is to basically, just let's see what is a B indicates. A small b. B is nothing but bold, right? It's basically bolding that data. I selected a particular column, right? So it's bolding that data. Okay. Okay. Now this I want to do sorting on based on the residential memory. So shift R. Okay. So now what you are doing, at a time you are at a single glance you are checking the process which is taking high memory, the process which is taking high CPU, the process which is taking high residential memory. Okay. Okay, now here there is a one more command, that is a small d, to set the delay. So basically what is happening, this CPU, this sampling occurs every few interval, every few seconds, right? You want to delay it, you want to delay it after every 10 second or 5 second, right? So you can type keyword d and you can change the delay. It was 30 second, I want to change it to 3 second, right? I was on third window, so change the timing for the third window. Let me shift to window 1. I want to change the delay. Here again it, okay, it's changed to 3. Okay, 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 okay. Now you suppose that identified the process and you want to kill that process, right? So let me just get help, and here if you see there's a k is killing the process. Okay, so you type, you are on window second, you can shift to any window, right? It give, okay, you can type k keyboard and it's giving you the process ID. So you can choose the process ID and you can enter, and you can enter the process ID and hit the enter button. It will kill the process. Okay, I'm not killing this time. Okay, okay, suppose that, yeah, there is one more command I wanted to show you, the R. You want to change the nice value of the process, right? So suppose that you want to give the highest priority for that particular process. You are running some Java process program and you want to give the highest weightage or highest value for that process, right? So you can change the nice value for that process. So if you identified the process ID, you can type R. Okay, suppose that this is the process 2554, so you can type 2554 again 55. Okay, re nice value. So suppose I want to give 10, 2554. What happened? It's a 2554 minus 10. What's saying? Permission denied. Okay, I need to be a root user, then only I can change. Okay, to give the topmost priority. So let me again try some 2554. Let me give normal priority. So normal priority is allowing to change nice value, but if you want to give a high priority, it's not allowing. Okay, so that's all. Like you can use this top command to understand which process is taking high CPU, which process is taking a high memory, right? So all these things you can easily understand via this top command. Okay, so here I have listed all the input parameter which I have used for filtering out, for checking the different design, or to checking the different values in the top command. Hope this video been helpful for you people. That's it from my side. Okay, kindly do like, subscribe and share this video. Thanks all. Thank you for joining.